Hello students, in this lecture let us solve this problem. We have to show that a tree has at most one perfect matching. So we have to show that a tree will have only one perfect matching and it cannot have more than one perfect matching. So in order to show that, first we should know what is a tree. So let us see the definition of a tree now. A tree is a connected acyclic graph. So now if this is an example of a tree, so if we see here, there are no cycles in these graphs. So acyclic means there will be no cycle. So this is a tree and it is a connected acyclic graph, that is it cannot have more than one component. So there will be a path between two vertices that you choose in a tree. So this is the example of a tree and we have already learned what is a perfect matching. If every vertex of G is M saturated, then the matching M is said to be a perfect matching. Now using these two concepts, let us prove that a tree can have at most one perfect matching. So we have to show that a tree has at most one perfect matching. That is to show that a tree cannot have more than one perfect matching. So in order to show that a tree has at most one perfect matching, we have to show that a tree cannot have more than one perfect matching. So let us assume the contradiction. Let us assume the contradiction. So what will be the contradiction? We have to assume that a tree has two perfect matchings. Okay, so let us assume that suppose a tree which can be represented as capital T of some vertices and edges has two perfect matchings, and let us call those matchings to be, say, M and M dash. So we have assumed the contradiction that a tree has two perfect matchings, M and M dash. Now because M and M dash are perfect matching, by the definition of perfect matchings, we know that every vertex of G is M saturated as well it is M dash saturated. Because these two matchings M and M dash are perfect matchings, every vertex of G will be M saturated as well as M dash saturated. Now let us consider the edge set M union M dash, and let us consider the graph constructed by M union M dash. That is, let us consider the graph. So the graph will be on the vertex set V with the edge set. Okay, so we are going to consider a graph with the edge set M union M dash. Now since every vertex of G is M and M dash saturated, every component of this new graph formed, so every component of this new graph which is formed with the vertex set V and the edge set M union M dash will be either a single edge. Okay, that single edge, if it is a single edge, it will be common to both M and M dash. Okay, or it will be a cycle, So every component of this newly formed graph will be either a single edge which is common to M and M dash, or it will be a cycle. But this leads to a contradiction, because we have considered the graph T, which is a tree, which cannot be a cycle, because we know that tree is a connected acyclic graph. Acyclic means there will be no cycle in that graph. So we have ended up with a cycle, which is a contradiction that it is a tree. So because of this contradiction, our assumption that a tree, because we have assumed the contradiction, we have assumed that tree has two perfect matchings. It cannot be true. So our assumption is wrong. Therefore, we can conclude that both M and M dash are same. So M is equal to M dash. So because we have ended up with a cycle, it becomes a contradiction. So because of this contradiction, because this is a contradiction, because since T is a tree, so therefore there can be no cycle, and hence we conclude that M is equal to M dash. Therefore, we have showed that a tree cannot have more than one perfect matching, and hence a tree has at most one perfect matching. Hope you have understood this proof. Thank you.